First of all, thank you for everybody being here. This is uh, a really cool part of the school year where we get to see all of this come together, the work that these students have been doing. And well, most of you know Shoreland well enough to recognize that the whole purpose of Shoreland is to share God's word with kids, but do it in a way that's going to affect their lives and prepare them for the future in whatever road they choose. And these guys certainly have been blessed with that. So if you wouldn't mind, I'd like to start with prayer quickly, and then we'll get into some of the explanations and introductions. So let's pray. God, thank you for blessing our school year, even though this has been a strange ending to it. And thank you for the opportunities that you've given to the students here within this course. Be with them as they graduate soon and move on to the next portion of their lives. We thank you for the people involved here that are helping to guide them, encourage them, give them some feedback in a way that's beneficial and meaningful to them. And ultimately, we thank you for the Savior, Jesus, who lived and died in our place. In your name we pray, amen. Again, you probably know well enough, by just for those of you that haven't been as connected, Shoreland's STEM Academy really has 3 different tracks. So we've got computer science, we got biomed, and then we've got the best track of those 3, which is engineering. And the engineering design and development course, which these guys have been in, is the capstone course. So they started, at least most of them started as freshmen in our intro to engineering design process, recognizing the design process. And now they've got the opportunity to, by the time they build some of those skills along the way in year 2 and 3, they get to this capstone course and again, go through the design process, but in a much more detailed way. So I'm the first year teacher of our engineering track, and then this capstone course, obviously, Tim Milkey, who's on the call with us, is the STEM chairman, and he teaches the principles of engineering, which is our year 2, and then also aerospace, which is year 3. And then we also have Paul Scriver on the call. He is the president of Shoreland. I think most of you know him as well. Paul, Tim, do you guys want to say anything wonderful to the group? Okay, go for it.
Good. I'll say a few words.
Or not.
Go ahead, Tim. I'll let you go first. No, I just want to say thanks to all the...
Yeah.
Paul,
no, to all of you who are presenting this morning, it's been a journey of 4 years for you, right? And you're the backbone of what makes our STEM program, the engineering pathway, what it is. And we're certainly appreciative of the tremendous amount of hard work that you guys have done in getting to this point, and we're extremely proud of you. And we're excited to see how God uses you as you pursue future vocations and ways in which you can serve Him in your life of Christian service. So God's blessings to you today, and certainly thank you for giving us the opportunity to be a part of your lives and to help encourage you in using these gifts that you have in the way that you've used them. So thank you and God bless.
Thanks, Tim. Am I on, Pete? Can you?
You are, sure.
No, just thanks to all you guys for joining in. And just, I don't know if you've heard that Shoreland Lutheran High School qualified and earned the title of a distinguished school in regards to our STEM program. There's only 143 schools nationwide that earn that distinction. So we are extremely thankful for the dedicated work of our STEM team, and also all the young people that are part of that put us on that elite group of schools that can be called distinguished. So, and you're part of it too, by being here to help the EDD kids finish up their products. It's a necessary part of the program and certainly plays a part in qualifying us for a distinguished school. So thank you, and look forward to the presentations today.
Thank you, Mr. Scriber. The students, I think we'll have you guys introduce yourselves right before we do the brief recap of your presentation that's already been out, but they don't necessarily know who all the judges are today. So if you guys wouldn't mind just sharing who you are, what you do, and your connection to Shoreland. I'm going to start in the top left of my screen, which might be different than yours, but Mr. Hoppy, that is you. So if you want to introduce yourself.
Sure thing. Good morning, gentlemen. Ladies and gentlemen, I'm not quite sure who my audience is. My name is Pat Hoppy. I'm the division chair for engineering at Gateway Technical College. I've been a practicing engineer, a biomedical engineer since 1993. And I have to tell you that the last 4 years that you've spent studying engineering is really just the beginning of all this for you. I sincerely hope that you continue on. We need more great professionals in our profession, and from what I've seen of your projects so far, I think I'm justified in calling you a professional. So well done, and I'll turn it back to Peter.
Thank you, Mr. Hoppy. Mr. Strutz.
Good morning. I am I'm a retired engineer. Worked at an InSinkErator the last 30 years of my career, mechanical, electrical, and environmental. And I've been working with the Pete and Tim in the engineering program for their last 5 years, actually. So but I always enjoy working with the students. So thank you.
Thank you. Mr. Watson.
Yeah, good morning. Dave Watson. I'm one of the owners of Drive Systems Technology. Our field of expertise is electronic motor controls, and the applications are many, but our specialty is kind of web handling, printing presses, paper machines, plastic machines, etc. So my level of training is an associate degree in electronic technology with 30 years of learning by the School of Hard Knocks on what works and how to make it work and how to stick with it to make it work. So I can appreciate the challenges that the kids that ran these projects went through. My connection to Shoreland is my wife and I are members at Faith Lutheran in Antioch, and our two daughters went through Faith and Shoreland. So we have a long connection with Shoreland and appreciate all the work being done.
Thank you. Mr. Krause?
Hi, Dave Krause. I'm currently an engineer at Google. I'm a computer software system engineer for about 30 years now. My connection to Shoreland is I'm currently on the board of directors. I've had a number of kids go through Shoreland. I had one finish the engineering program last year. She's a student in mechanical engineering at UW-Madison now, thanks to all the help from the program there. And I did spend a little bit of time this year, I think just one meeting with one of the teams here. So I'm just an expert witness, I guess is the right, I don't know what the right word is, just watching today. Thanks.
Thank you. Mr. Adams. I think
okay, I'm muted now. Yes, I'm a retired engineer. I worked for Underwriters Laboratories for 43 years, and my connection to Shoreland is I've been helping the two engineering teams that are presenting today during the course of the school year, and I was a helper last year also.
Thank you, Mr. Adams. Appreciate it. Mr. Kirkman, I think might be your audio is not working correct. So if you want to chat, or if you want to write anything in the chat for us, that would be fine. And while you're doing that, Mr. Fee, you want to introduce yourself?
Yeah, hi, my name is Ray Fee. I'm the manager of the clinical engineering department at All Saints Hospital here in Racine. I've been in the biomed engineering field for 35 years. I'm connected through Shoreland via my son, who is in the STEM program there and the robotics program.
Thank you. You guys can see in the chat, Mr. Kirkman's from Rockwell, and he was with us last year as well. Well, Mr. Fee was, and Mr. Krause, you were here last. Oh no, you weren't here last year because your daughter was presenting. Conflict of interest. But we have a few people that have been here for this type of thing before. And lastly, Mr. Kocha, Hugh has been here in the past too. You want to introduce yourself? Oh, I wonder if he's here. It looks like he's on, but maybe not. All right, well, if we get a chance to later.
Yeah.
Oh, you are, okay.
Okay, hi, I'm Tim Kocha. I've been involved with this day, the STEM judging for the last couple of years, so I've been pleased to be able to be a part of that. Hope I'm asked back again in the future. And I've also been involved in Career Day for the last 2 years. So I am connected through Bill Strutz. So Mr. Strutz has been a co-worker of mine for many years at InSinkErator until his retirement, and asked me to be a part of this. So I'm glad to be able to help out this year. Instead of judging, I'm helping by being an advisor for the
All right, well, thank you. Appreciate that, guys. I'm going to share with you just some reminders before we get started. You may want to have this email up that I sent to you because it's really got the links that are needed. So hopefully you had the opportunity to view the videos in advance of the student presentations, and I think that ended up being a wise thing to do just because of the nature of this Zoom meeting and how things get kind of disconnected at times. And we did have to do a little video editing, so that worked. You also have the documentation that the students did. And one thing I realized, I didn't really indicate this too well in the initial email, but as they follow this design
and you guys are staying safe and healthy?
This is the process that's laid out by Project Lead the Way. And you'll notice that different steps in that process are labeled as A, B, C.
So far, I will tell you that one of my students came down with it.
And that A, B, C, D, it goes through about L or even a little past that. It matches up with the documentation that they put together here that you read through. It also matches up with how they laid out their presentation. So you might have seen them referring to element B, element C, and so on. And that we tried to also match that up with the rubric that you had been given. That looks like this. And to give your assessment, it doesn't actually say it, but problem statement is really element A. Problem justification is really element B. Okay, so as you guys look at that and try to offer your feedback through that rubric, you'll see how that matches up with everything if you didn't already kind of pick that out. Okay, the schedule for today, we're already a little bit behind. That's my fault, but I think we'll get caught back up here in just a second. Just a reminder, if you can mute yourself as whenever you're not speaking, but feel free to unmute yourself at any time and ask a question or give some feedback. Okay, I'll share my screen as needed, so I've got those documents ready to go. If you want to reference that, I'll pull that up and you just say go to element F or whatever it ends up being, and I can share that so everybody else knows what you're talking about. And I believe that is it. So we will follow this schedule here. We'll have a quick recap from the Rubber Rollout Runways group, and then time for question and answer. And then you can either do this during that time or after we're done with all the question and answer. But if you could go to this Google form, and the Google form that looks like this is really just a reflection of that rubric. So you'll see the same things where it says, The first one on this form looked like this problem statement, gave you a 1 through 5, and gives you the opportunity to rank 1 through 5 and add any comments as you see fit as well. Okay, questions with any of that before we get started? All right, so Rubber Rollout Runways group, that was Brandon and Jack and Noah. Did you have somebody designated to give us kind of a recap just so we're all on the same page with what you did?
Yeah, I can give a recap.
Okay, thank you.
Okay, so at the beginning of the year, our group, we originally were gonna go for designing some new sort of screwdriver or drill attachment that would make it easier to get into these hard to reach places. But after Mr. Gum found something that sort of solved that problem already, we rebooted and decided to try to design something that would assist with the process of rolling up and transporting these rubber rollout runways that we, especially at Shoreland, use quite often for track and field or speed training. And the problem is that they take a long time to roll up by hand, and they're really heavy. It's hard to roll them up straight. And then the process of transporting them is a really difficult one because you got to lift them up and onto some sort of like pallet jack and then push that all the way across the track. And it just, so we were able, looking at all that, we came up with the problem statement that rubber rollout runways are laborious to roll up and transport. And so first thing we did after that was we had to get some justification. We were able to do that by sending out surveys to people at our school and around other schools who are dealing with these rubber runways. And we ended up finding out that lots of other people were having the same problems as us. And when we were looking for patents and stuff, we didn't find anything that was solving the problem we had laid out. So then we were on to sort of designing and brainstorming for this, came with a few specifications and look at our constraints. And then we each came up with 3 or 4 initial designs and then put them all through a design matrix, sitting down, talking to them together, coming up with a final design that we worked through in Element G. And then just a few days before we were sent home for the school year, we had done some talking about potential edit to our final design, getting rid of some of the rotating parts that we had designed because we feared it would be unstable, not durable enough to withstand the 540 pounds that each runway weighed. And we talked instead about using these scissor jacks with the heavy duty ratchet strap to lift the runways off the ground instead. And then we got sent home for the break. We already had that edit in mind. And with the quarantine and stores being closed, materials didn't work together, we had to make another on-the-fly kind of change to our design if we wanted to try to get our physical prototype done. And that was with, you can see it in the documents, I believe the scoop. We originally planned on having almost like a plow to force the runway to roll up over itself, similar to what we do by hand. And it was going to incorporate some sort of rollers, which was a recommendation from Mr. Kocha because just of the extreme friction that those rubber runways would be producing and their weight as well. But since we were not able, with the circumstances surrounding the virus and the quarantine, we weren't going to be able to get any kind of plow-shaped scoop going. We had to change the scoop design to be L-shaped bracket with a few, like I think they're called bed rollers. So same concept, rollers that would push the runway and force it to roll up and over itself. The rollers being there to reduce the friction. And then as well, since we didn't have the entire full size scoop, I suppose, just that little L-shaped bracket, we had to mount it on a vertical slider if we would want it to work, because as the runways were rolled up, their diameter would increase and the height of that L-shaped bracket would have to increase with that diameter increase as well. So the runways would push it up as their size increased. And unfortunately, we weren't able to, just due to everything and not being able to meet, not being able to get certain things, we weren't able to get our entire physical prototype completed. We were able, or Brandon was able to get the frame welded, get some handles on there. And while Brandon was working on that, Jack and I were working on the testing plan, and I spent a lot of time working on, because we knew we weren't going to be able to get the physical prototype done, I worked on modeling a 3D prototype of what we thought this new design would look like on Autodesk Inventor, and I have screenshots of that in the documents. And so it didn't turn out exactly how we expected, exactly how we wanted due to the circumstances, but I still thought it was a lot of fun. Good to get into Autodesk and sharpen up skills on that, and I think we all learned a lot despite what happened.
Thanks, Noah. And I mentioned that in the email, but I'll reiterate it now. Typically, we would be going through a testing plan and then carrying out that test, gaining feedback, and then going further with that to say, here's the adjustments we would make, or if we had time to actually make those adjustments. And just because of the circumstances this year, that didn't happen. So we got through pretty much just a testing plan. You'll see the other group had a little bit more to show with their prototype. But that's, that's kind of what we ran into this year. So with that, I guess I'd open it up now to any of you as judges, or those of you that had been serving throughout the year as expert helpers, to ask any questions to the group, or to offer feedback on what you saw in their presentation or read in their documentation.
I'd like to just chime in here by saying I really appreciated working with Brandon, Jack, and Noah. It was a nice experience. Glad to be able to help them out with this project and offer some hopefully helpful insights to help move the project direction along for them. I do have a couple of comments and questions. First of all, again, I think this was a really great project choice, because having worked at Snap-on, I can tell you that there are a lot of solutions in the market already for driving screws in hard to reach places. So that might have been a really, really tough niche to try to address. So I think this is a really unique product opportunity that, quite honestly, I think this could be commercialized. Seems like an unmet need that the interesting thing to me is that it's so unique, and it's something that, they always say that people will be willing to pay for something that they can't easily do or make themselves. So this would be something that if you had a robust solution that went to market, it's much easier for somebody to buy something that you've developed and designed than to try and fabricate something from scratch themselves. So I think this is a legit product concept. And so I think that's pretty cool about this project. One question I would have as I went through the video, and nice job on the video presentation, by the way. As I went through there, one thing that came to mind, just a suggestion, you had come up with a price target, a selling price target of $200. From what I can tell, from what little bit I know about, that market, which is not much, but it seems low, in my opinion. And I would just suggest, they say the quote is, you want to charge what the market will bear. That's the old term in Econ 101. So in other words, don't base your target price to the consumer based on manufacturing costs. I know in the video you mentioned materials and labor, to manufacture this. If it costs you $10 to manufacture, don't say, okay, then we should, mark it up 100%, so let's sell it for 20. Seriously, if it costs you $10 to manufacture something, but a consumer will reasonably pay $1,000, you charge $1,000. And in this case, regardless of the manufacturing cost, I think I think the market would bear considerably more than $200, considering this is something that, a large organization, colleges have big budgets for their athletic programs. And you would only need one or two of these. So it's not like they have to buy dozens of these. So I would just suggest, as far as setting your price on future projects that you'll work on in college and in your professional careers, just keep in mind, charge what the market will bear. But nice job.
Thank you. Noah or Jack or Brandon, you might have already seen this in the chat. Mr. Kirkman said, you mentioned a couple things and maybe you want to address any of them. Not clear, the team investigated the statics dynamics of the problem. So first, the amount of torque necessary to roll up 100 feet of runway, the bending moments of 500 pounds, structural requirements of the roll rod or gas engine to drive it. Any of those that you want to talk to about any kind of research that you had done or not done?
Yeah, I think with the roll rod one, I think he's talking about our initial design where we were gonna have it up on and rotate it. I think that's kind of why that's why we decided against that those few days before the break started, was because we figured out that would not work with the 540-pound roll being rotated up on that bar. So that's why we went against that. The gas engine, I think that was something we decided against when we were initially starting our brainstorming, because we wanted to avoid having a need for power other than manual power if necessary, just because being able to just have the people do it would be a lot easier than needing to have a heavy gas engine or other things just to complicate it. We just decided that manual power would be the best. And yeah, those other calculations, the amount of torque, I don't think we ever got around to actually calculating that. And the free body model analysis, is that like an Autodesk or something, some sort of stress analysis? I was looking at trying to do some sort of analysis on Autodesk or a different program, but I did not have enough time to get around to that after I had modeled all the pieces. I wasn't able to figure out a super quick way to do it with what I had done.
Mr. Fee is asking, what are the brackets for in the left and right arm picks for? And let's go over to this one. I think he's talking about are you talking about in this model, the CAD model of it?
Yes. Just up a little bit from what I can see. Those. What is that bracket on the side of that arm?
Those brackets are for our handle, because the width of our frame when we're rolling it up wouldn't fit in a standardized door. So, and sometimes for track, when it's raining out or something, we will bring the mats inside. And so basically we would put our handle on the side and then when we put it there, the width of our frame would be able to fit through those doors. It's more of a transportation aspect.
Any other questions, comments, feedback?
Yes, this is Cliff Adams. In going over the final report, I think we had a few missed opportunities. With the problem statement, you had to read quite a ways into the document to find out the roll was 3 feet wide, 90 feet long, and 540 pounds. We still don't know what the actual diameter of this roll is. It's not defined anywhere, and it would probably have been a good idea to add a glossary term in the as part of the problem statement to define what a runway roll is. And the other part is I agree that there's a lot of missed opportunity for calculations. Having a every other month visit with the team, I think overall they did a wonderful job in the time that they had. But there was a lot of ground to cover in a relatively short amount of time. The fact that the development and everything, they didn't look at what amount of force was originally required to push this roll without any mechanical advantage or without any equipment. And they missed an opportunity where if they had stuck with one of their earlier design considerations, they could have had some mechanical advantage or gearing in the crank mechanism to roll it up. And that would have made it easier for one person to handle. Unfortunately, they decided with their criteria to go with a somewhat different design that does not appear to have any mechanical advantage in dealing with the weight of the roll. And the other thing is the prototype that they came up with doesn't bear resemblance to their final design. So they did not go back to their final design to update it to include the features of their prototype. And of course, the calculations for bending moments and strength were not part of the evaluation or design analysis. And that's my comments.
Thanks, Mr. Adams. And Mr. Kirkman added a few more in the chat. If you haven't seen those, you can kind of read through that. Anything else for this group as we kind of close up with this?
Yeah, Dave Watson here. I have a couple of comments, if I might.
Yep, go right ahead, Dave.
Okay, sorry about that. I didn't know if I was working or not. So overall, this is a very good job. I do recognize the shortcomings in the original design and calculations, and I guess the survey that was used for justification of the project asked if a roll could be rolled up and transported by one person. But as I understand the final design and the final result, it's not a one-person machine. And I think Cliff and others have alluded to the reality that if the mechanical forces were calculated and such, that would have been clear that that this was not going to be a one-person machine. It gets complicated. You set a target value of $200, which I agree, if this actually was a one-person machine, it would be worth many times that. And of course, it would cost many times $200 to fabricate it with the mechanical advantage, maybe the motorization. So, you know, the idea is valid. It's a necessary product, I think. It's probably worth way more than the original estimate, but of course it's going to cost a lot more to build. But all that being said, students did a very good job of presentation. The written documentation was clear to me, and I thought the testing procedures were explained very well. It's unfortunate they weren't able to be carried out. We'd all like to know how they really work, but that's not going to happen. So those are my comments. Good job overall.
Thank you. Any others? Oh, Mr. Hoppy, go ahead.
All right, thank you very much. So I'd like to address the design team and just tell you that I really appreciate what you've done. You followed the design process very well, and I think with the influx of COVID-19 and the sudden changes that you had to make, I think that was a lesson well learned. I'd like to tell you that every design project I worked on went smoothly, and we had no unexpected things come up. But the truth of the matter is that never happened. Anytime things are going too smoothly, we all got scared because we knew something was going to fall. So you handled things very, very well with that. And what I appreciated was, as you saw things within your design that you needed to change, you were willing to make changes. Too often I see new teams that, or teams that are new to engineering design, will get an idea and will do everything they possibly can to follow that idea to completion, even if it's the wrong path. And I was pleased to see that you didn't fall into that trap. The presentations were very well done. I looked through your documentation, and I thought that was done equally as well. And I just wanted to say congratulations and thank you for doing such a great job. Back to you, Peter.
Thank you. All right, I think we should move on to the next group. So the seafood group, who did we have that was going to give a brief recap for that one?
We kind of had a couple people doing it.
Go right ahead, Derek. Thanks.
So we are the seafood group, comprised of Ben Barrett, Michael Zhang, John Schmidt, and myself, Derek Orkart. To start off, I'll just recap our problem statement. Restaurant customers may be unaware of the nutrition facts, allergens, or appearance of their food prior to ordering, preventing the customers from ordering food that best fits their needs, which results in a suboptimal restaurant experience. Some of our job roles were Ben and I focused on the aesthetics of our website/app, and we focused more on organizing the information and the research behind it. And John Schmidt and Michael Zhang focused more on the coding aspect of it. Michael did the back end of the code, and John Schmidt did the front end of the code.
Yeah, so throughout the year, we've taken a computer science approach to the problem. We did consider some physical product ideas and overall decided they'd be ineffectual. And so really our ultimate goal that stemmed from the problem was to create a centralized restaurant menu app that anyone with a browser can access, which is the main reason we decided on a web app rather than a native one, which is what we had in mind for a while beforehand. And in the end here, with the safer at home orders, we turned our focus to creating more of a framework that can eventually be expanded upon and scaled up, mostly because restaurants are busy with other problems right now. And you may notice that you've probably noticed that our prototype is quite different from our final design. And that's mostly because of time. We used the last couple of weeks here to get our prototype working, and we didn't have time to update our final designs. So.
Anything else from that seafood group, or you feel okay about that's it? Okay. And then in that case, we will move into the question and answer session. Anybody have any comments from what you saw in the video presentation or in reading through the documentation?
I guess I'll start off again if I could. I didn't have any experience or exposure to this project prior, since I was assisting with the roll-up runway. So this was, you know, when the presentations were sent out in the last few days was the first time I saw it. Again, my first thought is this is a really great project. I think from what I know, there's an unmet need. There are a lot of apps out there with nutrition calculators and so forth, but I think this would be a really unique unmet need. One question I had for the team, it seemed like your presentation focused on the architecture of the app itself. My question is, who's populating the app with all this food data, all the allergen information, all the nutritional information? I mean, you've got dozens or hundreds of items on a menu at any given restaurant. Then you've got thousands of restaurants potentially. Who is this crowdsourced, or are the restaurants expected to populate this app in order to draw traffic into their businesses? I didn't, unless I missed it. If I missed it, correct me if I'm wrong, but I didn't see anything in the presentation about who was populating all of this food and allergen data into the app.
Yeah, so I guess our idea was that the restaurants themselves would be entering data probably into a spreadsheet or something. With our time constraints, we haven't gotten around to actually kind of fulfilling this yet, but we've definitely talked about writing scripts so that restaurants could just enter the data themselves after we reach out to them and talk about it. And then a script would enter the data into our code.
And John, or maybe Ben, I remember you were kind of working on this too. We had initially said, let's get a few restaurants to see if they can give us some of that data to plug in here. And you reached out, I think it was Culver's specifically, that just explain what you ran into and maybe plans that you would do differently, or in the future how you would get restaurants to buy into this.
Well, we reached out to a couple restaurants. We got a response from one, and that was Culver's. Unfortunately, they were afraid of any legal issues in case something happened to one of our users. They didn't want any backlash from that. So that was the main issue we ran into. And in the future, we would kind of like to. It made it difficult because they have their own nutritionists and dietitians and stuff like that to enter in and update all their information on their menus all the time. And it made it really difficult for us to enter the information without risking anyone else's safety.
Yeah, that was one of my questions I was going to have, is the legal issue that you would have if somebody ate something inappropriate and got hurt or something like that. But another question I have is one of them, the spoken one, it looks like they have a good application for that, but the only input is from users. And I'm wondering if that's not because restaurants don't want to do that. Put in their own information into it. It would be very time consuming and legal issues involved and things like that, that restaurants aren't going to want to do that.
Thanks, Mr. Fee. Mr. Kirkman had some comments there in the chat if you haven't seen those as well. Any other questions for the group or feedback?
Dave Watson here. I have a question or two and a couple comments. First of all, this is way outside my field of expertise, so I'm challenged at critiquing this and knowing what's a viable path to developing the project or not. But I thought that I thought the justification for the project was legitimate and well stated. I thought some of the written documentation, the presentation of the written documentation was difficult to weed through. Just the pagination was poor in some places. There were some cut off sentences, some poor paragraph spacing. So the written justification was lacking. I think the information was there, but it was poorly presented. The video presentation was fine. Again, because I struggled to understand the level of detail that particularly Michael was getting into. I had to keep pinching myself to keep from my eyes glossing over. But clearly, you guys really dove into this and put a lot of thought into it. Some of the questions that have been raised already are certainly valid. And it's, I guess, part of developing the product and then feeling out the market is you just have to go through this stuff. I thought they had a good written critique of other solutions that were on the market, though didn't specifically address their product. The rubric asked for graphics, and I didn't see many graphics, though. There was plenty of written critique, just not a lot of graphics on other solutions that possibly exist. Again, the written documentation, even the video presentation, I couldn't really see how your final design was chosen. Maybe I missed it. I saw good discussion on the alternatives. There were several options submitted, but I just couldn't understand how you got from whittling down all your options to the one you chose. If I missed it, apologize for that. And then I guess the other comment regarding the written presentation, I guess I mentioned the pagination and such. There was one bar graph in particular, and I looked at it for quite a while. It's a red bar graph, horizontal bars, and I don't know if that just didn't render properly on my screen or if I'm just completely missing the boat, but that one was really hard for me to understand. So again, the combination of the written documentation, the video presentation, I was comfortable with, but I think the written presentation was something to be desired. And I guess the last comment I have, and if anyone can educate me in this regard, they mentioned that the prototype fell short of their original design goals, which is not the first time that's ever happened. But I'm not a programmer, but it would seem to me that this type of product that is programming, it's a programming project, not a physical assembly product. Explain the time constraints and how the recent events complicated developing this software app. And I'm asking really because I don't know. I don't know how this stuff is developed. I know when I program, I sit at my desk and I type away. I can do it in my basement. I can do it at my desk. So help me understand how the team struggled to complete this project even during the lockdown. And I'll just mute my mic and listen. Thank you.
I guess I'll address the problem of the time constraint a little bit. Because we first started when we first started the project, we aimed for a app, like a local app, as John has talked about. So that would be a completely different path than what we ended up using, because we ended up going with a website, which we have none of us, even though John and I have dealt with coding and computer science before, we have never really learn about how the whole web application works. So when we decided to go this path, we have to learn kind of from the start the whole process of designing a web application, and that itself is a very technical, and sometimes it's just really abstract, and since we have to learn it mostly by ourselves, it's pretty time consuming. And given when we started prototyping, there's only like 2 months and a half or something left, and given the amount of material and resources that we could use, and how much we have to dig into that in order to actually use it, and without any I guess without a lot of professional help at hand, we really don't have enough time to investigate and dig deep into the technical stuff to make sure that our app works as we originally thought that it would. So then that's when we decided to use a framework to just build a framework, and from there we can build on top of it later on in life when we gain more professional knowledge about computer science or about how to market it. Yeah.
One other thing to add to that, just so you understand, Mr. Watson, that when we sent kids home and said you're not allowed to come back onto the campus, and now we're going to do this learning virtually, the structure that we set up was essentially half of the time in person, going through instruction and working with one another, for the sake of students that had other brothers and sisters at home. And so I understand your question, because I think for the two groups, the virtual learning shift that we had to go through was, a steeper curve for the other group that was doing the physical prototype. But there was definitely less time that they were designated, and maybe, helping the team focus on what they needed to do, that was established as their time to work. So there was still a little bit more of a time crunch than what they originally had. But in hearing the group present, I think maybe there's a little bit of a the planning of their Gantt chart and how they laid out everything they need to get done throughout the year. They might have been a little bit off with the time that they thought they could get everything done in. If you haven't seen, Mr. Krause posted his biased opinion of the group because he was helping them, so you can read through that. And thank you, Dave, for your help along the way. Any other comments or questions? Mr. Hoppy.
All right, thank you. So onto the design team, I thought it was a job well done. I really liked that you you saw it as something that you had to do. I like the fact that you moved to a web-based application, because now it stopped being a either an Android or an iPhone application, and now it was something that you could access with anything, and I think that's important. I will tell you that I'll share a little background. For many years, I wrote preventative maintenance software for hospitals to track all their medical electronics. And one of the things about writing software where people will input data is that you need to make your software user-proof. I will tell you that if you let them type in the word peanut, they will spell it 5 different ways, and now your software is going to have to search for all those different ways. For any of your data input, being able to have drop-down screens where you already have the data listed and they simply select that really saves you a lot of coding headache after the fact. Writing software, as you will find if you continue doing this, writing the actual application, I could write just about any application in 1 to 2 weeks, and then I would spend another 2 or 3 months making it user-proof. And that's really what you need, is that it isn't just to get it to do what you need it to do, but now how can you prevent it from doing things that were inadvertently done because somebody entered something wrong. And that's where you're going to spend a lot of your time. And I really hope that you continue down the path of computer science. I think that we need talented engineers in that area. I appreciate the products that you all make. So I thought, job well done. I like the fact that you did prototypes of the screens. I did that a lot. That's really important. If you can't prototype your screen to get feedback from a potential audience, you could be headed down a road that you're never going to have any sales. So well done with that as well. And I just wanted to say good luck to you in your future. I hope you continue down the computer science pathway. That's a great career choice. Back to you, Peter.
Thank you. Any other comments or feedback? All right, well, if not, one reminder that if you haven't already filled out the response rubric, and I know I had a few of you designated as judges that would specifically do this, but any of you that were here as witnesses to this or helping throughout the year, the more feedback, if you're comfortable filling that out, that would be welcome and encouraged. You'd need to do 2 of these, essentially, 1 for each group if you haven't already started plugging that in. But what I'm going to do then is take a look at that and share that with the group as well to give them a little bit more visual of some of the things that we've been able to talk about today. But again, to all of you that were here, thank you so much. This is a big part. You know, Mr. Watson, you kind of said, especially with the app group, that this was over your head. How do you think I feel? You know, they started going down that road. Okay, sounds good to me, guys. Go talk to Mr. Krause because he actually knows what he's talking about. So thank you for being here as those experts and filling in for gaps that us as instructors in this STEM pathway don't necessarily have the training for, but because that gives these guys a lot more guidance and a lot more wisdom that we might not be able to offer. So thank you for your time. And I know watching a couple of videos and looking through pages of documentation in the short amount of time that you had was not an easy task. So we appreciate it from a Shoreland perspective, but I know all these students appreciate it too. So thank you. If you're an expert helper or judge today, you can sign off. Students, if you guys want to hang out for just a little bit longer, I've got a few things to share with you. But God's blessings on your day. Thanks once again.
Thank you.